Hello, Tor Lacey here with a lecture about streams and stream-related landforms. This is for Earth Science 110 in the summer of 2020. Some of our learning objectives include compare and contrast among the three types of stream channels, identify where each stream occurs along a typical stream profile, describe the channel bottom and sediment carried by each stream, identify erosional and depositional landform features in photographs and topographic maps, and make geologic interpretations using this data. Explain how stream-related landforms are formed. Let's consider streams in terms of their place in the water cycle. Most of Earth's water is contained in the oceans. From there, water evaporates, the water vapor rises, condenses to make clouds, which yield precipitation. Rain does one of two things when it reaches Earth's surface. It infiltrates into the ground to become groundwater, or flows over the surface as runoff. It doesn't take long for this runoff to become confined to a channel and flow downhill as a stream. So streams are any water contained in a channel. Larger streams are called rivers, while smaller streams have names like brooks or creeks. The bottom of a stream channel is called the bed, and the sides of the channel are called the bank, or banks of the river. The stream profile represents a typical stream's path from start to finish. The head or headwaters are where the stream starts. Here there are many smaller channels, tributaries, that are contributing water to the main channel called the trunk. As the stream flows out of the mountains, its gradient or slope decreases, causing the stream to become more curvy or sinuous. In this way, the type of stream channel changes as the stream works its way towards its base level or mouth. Here the stream stops flowing as it enters the ocean, lake, or even a dry, flat valley or basin. Here's another perspective that includes the typical locations for each of the three types of stream channels. Near the head of the stream, where we have the steepest gradients and water is flowing with the most energy, we have the straightest channels. These bedrock channels are also called straight streams because of their straightest course. It's not perfectly straight. Streams never are perfectly straight, but it's the least sinuous. Braided streams happen where the gradient decreases, deposition happens, forcing the stream flow to flow around the piles of alluvium in the channel, creating braided streams. Meandering rivers exist where the gradients are the most gentle, the sinuosity or curviness of the stream is the greatest. And this is going to be closest to the mouth of the stream. Your stream is flowing across this valley and emptying into a lake. Profile of the stream can also be roughly broken down into three zones: the zone of erosion, the zone of transportation, and the zone of deposition. In the zone of erosion, erosion is the predominant process, although some sediment is being transported and deposited as well. In the zone of transportation, this is where lots of sediment is being transported. And then in the zone of deposition, at the mouth of the river, deposition must happen. The stream stops flowing and it deposits its load. The geologic work of streams, erosion. Streams are the most important shapers of the landscape. This is done through erosion and deposition. The geologically destructive process of erosion happens because streams are transporting sediment, allowing them to do abrasion to the land over which they flow. So this makes them the most important erosional agent on Earth's surface. Think of them as conveyor belts of sandpaper cutting down into the rock that's in their path. This photograph here shows the Virgin River exiting this very steep-sided canyon, which has been created by the down-cutting action of the river. Streams also widen the landscape. We'll discuss this a little bit later on. All the rock that streams pick up and transport eventually is dropped off through the process of deposition. Think of this as the opposite of erosion. Deposition happens wherever there is a decrease in velocity and the stream loses some of its energy to transport its load of sediment. The sediment deposited by a stream is known as alluvium. So here the dump truck is depositing its load. The load deposited by streams is given the term alluvium. This is considered to be constructive because the accumulation of alluvium over time builds up landforms. Once a stream reaches its base level, the lowest level to which a stream can erode, it can no longer do any erosion and it will deposit any remaining sediment. This happens at the mouth of a stream. In this version of a stream profile, we have the headwaters here. The river is flowing, reaching a temporary base level in the form of a lake. Deposition happens there. The stream is flowing out of the downhill side of the lake to the ocean, which is considered to be the ultimate base level. There, the stream stops flowing and any remaining sediment will be deposited. And again, this happens at the mouth of the river. Stream channels. We have two categories of stream channels, bedrock channels and alluvial channels, giving us three different types of streams: straight, braided, and meandering. Bedrock channel streams, also called straight channel streams. No stream channels follow truly straight courses, but bedrock channel streams generally are the least sinuous or least curvy, and therefore are also called straight streams. They will be found near the head of the river profile, where gradients are the steepest, and they flow most energetically. In this way, they are doing a lot of downward erosion or downcutting, which develops steep-sided V-shaped valleys. This photograph here of the Yellowstone River is a great example of a straight stream. It's flowing with a lot of energy. We see a waterfall and rapids, and this allows for rapid downcutting into the land, creating these steep-sided V-shaped valleys. Any sediment deposited will be temporary and immature. Immature meaning that it's going to be coarse, so large size sediment, think of boulders, rocks that are more angular. They haven't had time to get rounded yet. On a topographic map, a straight stream will have a fairly straight path, and the contour lines reflect the steep-sided valley that contains the stream. The stream is at the very bottom here, with closely spaced contour lines on either side, representing the steep-sided valley that contains the stream at the bottom. Alluvial stream channels, braided. Alluvial channels are so named because the stream bed is covered in deposits of alluvium. This happens where the gradient decreases and the current loses energy, prompting the deposition of piles of sand to gravel-sized alluvium known as bars. Bars that form in the middle of the stream channel are called channel bars. These piles of sand and gravel-sized alluvium force the stream to flow around them, creating many intertwining channels, giving braided streams their name. The lateral flow of these streams erodes out a narrow floodplain, which is what the blue arrow is spanning across here in the photograph. Let's look at another braided stream here with a nice, easy to see floodplain, many channel bars. This is the area that will be completely underwater when the stream does flood. Associated with braided streams and some meandering streams are stream terraces. These are formed when tectonic uplift increases the gradient of the stream channel, increasing the stream's energy, triggering the downward erosion into the floodplain. This results in the establishment of a new, deeper floodplain, leaving the older floodplain or floodplains suspended above the stream and the active floodplain. So in this photograph, we have possibly 3 terraces suspended above the active floodplain. This could be an ancient terrace. Then we have a secondary one, the pretty flat surface there, and then this newest one, or most recent one, pretty clearly here. So this is where the stream used to flow. Tectonic uplift in this region caused the stream to flow with more energy, caused it to do some down cutting. It cut down into that past floodplain, down to its new position here, leaving the old floodplain suspended above. On a topographic map, braided streams look braided and are often associated with glaciers. The meltwater coming out of the glacier is loaded with sediment, which quickly is deposited as channel bars. Here's a photograph from Iceland. There's a glacier, and we have a nice braided stream here in the foreground with great examples of channel bars. Alluvial channels, meandering rivers. As a river flows farther from its headwaters in the mountains towards its base level, the gradient steadily decreases. As the gradient decreases, the stream's path becomes increasingly more sinuous. This sinuosity results in more lateral than downward erosion. As the stream flows faster around the outside of the curves, it does erosion, cutting away at the stream bank, resulting in features called a cut bank. In this way, the floodplain for a meandering river widens over time as the meanders extend further out by doing more cutting. In contrast, stream flow slows on the inside of the curves. Therefore, deposition happens and piles of alluvium accumulate, creating point bars. Meandering rivers are typically perennial, meaning they flow year-round, transporting fine sediments like fine sand, silt, and mud in suspension, which gives them a muddy appearance. Here's a photograph of a cut bank and a point bar on the inside of the curve. Oxbow lakes are another feature that's unique to meandering rivers. They form when a meander becomes so sinuous that it cuts itself off. The stream abandons the longer curved path for a new, more straightforward path. So we see that how that might develop over time here. The meander loops become more and more sinuous, eventually cutting themselves off in this case, and the stream takes the shorter path. Water isn't flowing here, so it becomes a lake. And as mentioned a couple of slides ago, meandering streams have well-developed floodplains. So we see how this may develop over time. We could start with a fairly straight channel stream, and with time and downward erosion, the gradient becomes less. As the gradient becomes less, the stream becomes more sinuous. With more time and more flattening of the gradient, the sinuosity increases even more. And with more sinuosity, you have more lateral erosion. With that lateral erosion, you erode out a wide, flat valley. Okay, so putting these back on this illustration that I showed you before, near the headwaters, we're most likely to have the straight streams. As we leave the mountains and the gradient decreases, deposition happens, and we get braided streams. And then out in the flats, where the gradient is the least, the streams are most sinuous, and we typically have our meandering rivers. Then we have these, incised meanders. An incised meander is a rare combination of a meandering stream and a bedrock channel stream. How could this happen? These form when the region over which a meandering stream flowed was uplifted, increasing the stream's gradient and downcutting into the bedrock. The goosenecks, pictured here, are in Utah and are part of the Colorado Plateau, a region that has been geologically uplifted relatively rapidly over the past few millions or tens of millions of years. As you have learned, streams are the principal erosional force on Earth, but all the rock removed from one place must end up in another. Let's take a look at a few prominent landforms that are the result of stream deposition. These form from alluvium that eventually becomes sedimentary rock over time. And in this way, this is a constructive geologic process. A common depositional landform feature related to streams are deltas. These form at the mouth of a stream. In this pic, we have a delta. These form when a stream enters a calm body of water, loses its energy, and deposits its load of sediment. Think of what happens after you shake a snow globe. On a topographic map, a delta will be the land jutting out into a lake or an ocean at the mouth of a river. Natural levees form during flooding of meandering rivers. The sediment being carried out of the stream channel by the floodwaters is deposited along the top of the riverbank, accumulating in long, narrow hills that run roughly parallel to the path of the stream. We have the river. This is the levee here. And you can see that the river now actually sits above. Its elevation is higher than the surrounding floodplain because of the buildup of the levee over time. Alluvial fans. These are common in semi-arid to arid regions where mountains are growing. And these are the kind of conditions that we have in the southwestern part of the United States. They form where a straight stream exits its steep mountain channel and flows out onto the valley floor. This causes the stream flow to abruptly slow and deposit its load of sediment. Because of the climate, this often occurs during flash floods. Death Valley has especially well-developed alluvial fans. So the fan being here, this being Death Valley. Here is the straight channel stream exiting the mountain. And there's the fan. If we look at it in profile view from A to B, that's the fan there. On a topographic map, an alluvial fan is going to be the feature being built out from the mountain front. Reading the contour lines, we see that it has this fan shape, a moderate slope leading up to the mountain front here. There's the stream exiting. That's it. Thanks for listening.